If I switch to ML.NET, is that kinda, yeah. Still looking for all the scenarios where we can use it, but where we can use it, we're using ML.NET. Yeah, although cognitive services are a bit easier than ML.NET. So if there's a cognitive services for that, then we preferred that. Yeah, we don't have to maintain our own models and try to figure out things. It just works. Hi everyone, we are live. And today I'm going to present to you machine learning, simplified for developers with ML.NET. So I am Jernej Kavka. You can call me JK. You can follow me on Twitter, GitHub, follow me on my blog. I'm .NET Foundation member, so if what it means is just I can get a little bit support from Microsoft when doing the user groups, but also if you like your libraries, open source libraries, go to Open Collective and give them some support. And recently, my main focus on .NET Core and cognitive services, and I added ML.NET to the mix to have a little bit of custom machine learning. And I'm also speaking at NDC Sydney for the first year, and you can find real-time facial recognition with Microsoft Cognitive Services. I'll be the last talk on Friday. So if you're coming to NDC Sydney and you'll stick around till the end, you can join me. So what I'm going to talk about today is about my story on how I started with machine learning. Basically how I managed to fail completely and how I basically succeeded in the end. But before I'll show you how I succeeded, I want to show you the machine learning, what it is in a bird's eye view, because if I just show you the solution, you'll be just like, oh, okay, I click that button, I import that, and then it's done. But if you know what the machine learning actually is, you'll be like, oh, when he clicks that button, all that stuff happens. So I think you'll have a little bit more appreciation for what's going to follow. So first, what I learned is you just don't simply learn machine learning just that quickly. And it all started with a goal, and that was, I have my bank transactions on the right, which are descriptions of the bank transactions. And all I want to do is get categories out of those bank transactions. And I was like, how hard can that be? I mean, I did some rule engines for bank transactions. There are like 4 of them on my GitHub. All of them failed because I was too lazy to maintain the rules. But, you know, what is the knowledge gap for that? So getting from here to here. Well, you have a bunch of frameworks. All of them are kind of very advanced. You have to understand about machine learning. You have to import data, clean data, and before you're able to understand how to use them, your weekend is already over, and you're like, nah, I don't want to do this next weekend. So you kind of drop it and never tackle it again. And the biggest problem with all these frameworks is that they're like infinite rabbit holes. You look at one phrase and it's like, oh, okay, what's neural network? And then you try to learn that, and then you see, oh, there are different shapes of neural networks, and then there is linear regression, there is some genetic algorithms, and you know, they kind of expect you to just know all of that. And even when you have one targeted thing, I want to just learn this, they just throw a lot of words at you you don't understand. And to understand those words, there's another infinite rabbit holes, and before you know it, your weekend is over. So I just want to get this done. And what can I do to get this done? Well, a year ago, ML.NET, Microsoft released ML.NET. And I was already hooked because what they said, it's built for .NET developers, which most of the machine learning frameworks are not. But then there's another thing, without any prior knowledge of machine learning experience. It's like, okay, now I'm hooked. And what ML.NET is? Well, it's Microsoft Machine Learning SDK that works offline, so you don't have to run it on Azure. You can if you have huge data set and you don't want to wait hours on your local machine. It's simple yet powerful. It's not as powerful as a lot of other frameworks, but it gets its job done without you spending too much time on it. It's been already used in Power BI, Outlook, Visual Studio, and many more for years. So it's been battle-tested framework, and what happened is that Microsoft just opened that framework to us, regular developers. If you already are using some of the ML models around, like TensorFlow or Onyx, you can actually import that model into ML.NET and use it. So you have a simplified API that uses an existing model, rather than trying to figure out how to implement those more complicated frameworks. And it has one of the most awesome samples I have managed to find on machine learning. That is code, and you can actually modify it and understand what's going on. And with that, I want to tell you about machine learning. Just a little spoiler alert. With ML.NET, I managed to make my first prototype in 1 hour. So just think about that when we get to the last part. So, okay, what is machine learning? Well, machine learning is just a process that where we build a model. And you can imagine building model like acquiring knowledge that we can then later use. And the second step is to actually use that model, which is like making decisions based on the knowledge we gain. And that allows us to solve complicated problems, because you can use algorithms to solve all kinds of problems. But the problem with that is that some problems are just not practical to be solved imperatively or algorithmically. And this is where machine learning can help you out, basically solve the problem. It can adapt over time. So if you look at the process up above, it's actually circular. So you build the model, you use it in production, and then based on the decisions you got from the machine learning, you can pipe it back to build a new model based on the new gained knowledge. So now you have a new model which will probably work better, but you'll have to verify it before publishing to the production. And all the results are probabilistic, which means, unlike algorithms where you can say, that's what the answer is going to be, and I am 100% sure that this answer is correct. With machine learning, it's more like it's likely to be correct if the confidence is high, but there's different kind of inputs that makes it appear that it's correct, but it could be way off. So you have to be a little bit careful what you're doing with machine learning. You have to think that every answer you're getting has a confidence level. And then that may affect the UI, saying, okay, if it's 60%, tell the user, hey, I'm not sure if that's correct, but it's probably correct, rather than saying, hey, this is correct. So what is building model? So what is the process of it? So first, we need to start with training data. The training data is the basis of machine learning. Then we add it into machine learning algorithms. We won't touch too much into that part. It's that black box, the magic that does something with training model, training data, and then we get back a model. And this model then, if we add an input and feed it into model, we get a prediction. So you can imagine that the input is like transformed into an answer with the help of the model. So the hardest part is getting the model. Once you have a model, you basically solve the entire machine learning problem. And what kind of machine learning are there? Because a lot of people, when they think about machine learning, they're like, yeah, it's definitely neural networks, right? And for those who don't know neural networks, there's just how we try to mimic human brain on hardware, but on a very, very tiny scale. But we have some simpler approaches to machine learning, like a linear regression, where you might have a simple line, which uses simple junior grade math. You can also have genetic algorithms, which literally generates thousands of populations, try out which one are the best, and only the best survive into next generations, and then you repeat that for thousands or millions of generations. And then at the end, you get not the best result, but the one that solves your problem. And lastly, I want to mention, and you probably have heard in your uni, at least those are the ones that I heard in uni, is decision trees, which basically just tries to figure out how can I make a graph of decisions based on the data I got in. So you could do this manually, but if you have like millions of rows of data, you probably want to automate that. But machine learning is a tiny bit more complicated, and the reason why it's hard to get into machine learning is it's a bit bigger scale than just the ones that I mentioned before. You can just say, okay, we have one huge category called supervised learning. So what is supervised learning? So you feed in very tailored training data into machine learning, and then the training data has a good mapping between what goes in and what you're expecting to be the output result. So a good example would be classification, where we have bank transaction categorization, and image classification, and customer retention in anything that you can put a label. And on the other hand, we have regression, which usually is used for forecasting and prediction. So if you want to predict the real estate values in 1 month, that's the thing you want to use. But then on the other hand, you have unsupervised learning, which is a bit more difficult concept to go through, because what it does is, here's the training data, but we're not really training for anything specific per se. It's more like we're looking for a criteria, or we're trying to cluster things, so it's a bit more complicated. And what allows us to do is, for instance, if you have data visualization, you can then condense that information into just a few data points, rather than trying to visualize all of the data. Or more understandable would be the recommendation system with help of clustering, and you're trying to figure out how your market is being segmented. And there's one more big category of machine learning is reinforced learning. So this is more like a real-time machine learning, where, for instance, if you try to train a car, you will do reinforced learning, hopefully in virtual machine, because the point of reinforced learning is to fail and then understand why it fails and try it again, but a bit differently. So you have to fail in reinforced learning, and that's what probably they used in Tesla as well. And this is very popular with game AIs as well. And if you look at ML.NET, at the moment it supports only the supervised and unsupervised learning. And our talk is going to be mostly focused on the classification, because that was my goal. But all my talk, the exploratory and stuff like that, would apply for all of them. But, you know, I would say this is the end of story. Now we can just go into machine learning. That's all you need to know on the high level. But that would be a little bit of a lie. You know, if we take the bank transaction categorization, there's another lower level of subcategory of this subcategory, which is called multi-class classification. And that basically, multi-class classification allows you to have multiple labels for different inputs, whereas you have also binary classification where you have only two labels, yes or no. And what you also notice is we have a bunch of stuff down below, like what Microsoft call them trainers. And why do we need trainers? Well, depending on what kind of data you have, is it big data, small data, diverse data, is it very similar looking data, each of those trainers will have advantages or disadvantages based on those specs. So, you know, if you learn for each individual trainer for which kind of data they're the best kind, you could just go through all of them and then say, this one seems to be the best one. But in reality, it's also a little bit of trial and error. Say, okay, two of them are good for big data, but I'm not sure, you know, what they mean with diverse data. So I'll try both and see which one gets me the better results. And, you know, what can you do with this machine learning? So, and how do you basically figure out what it is, what kind of classification? So for instance, do you want to do Twitter, whether figuring out whether tweet is positive or not, you can use binary classification. If, for instance, you want to do bank categorization, you can use multi-class classification. House prices prediction, you use regression. And for product recommendation, you use metrics factorization, which is unsupervised clustering. And as you can see, there's like, based on what you pick, the scenarios, you basically travel through that machine learning tree to figure out, okay, what do I actually need to know? And to give you a little bit more concrete examples, my favorite one is, say you have pictures of beer, but you want to just know what kind of beer they have, but you don't really have much data about it. What you can actually do is you can use multi-class classification and take the color of the beer. So you might have one machine learning that recognizes beer, and you then take the color of the beer. And from the beer, you can actually predict what kind of beer it is, because each kind of beer has a very specific color. And another example would be, say we want to predict usage. Say we have a company with tractors, and we want to figure out how many tractors do we need when. And we have traffic incident data, and we want to know when we need to reserve the trucks. Well, a good thing would be to predict the number of tow trucks needed on Friday. Because, you know, on Friday, you have a specific trend, and you can say, okay, we need more on Friday. But what you shouldn't be doing with machine learning, at least until you don't have more advanced data scientists behind you, and maybe oracles, is to predict exact time and location when you need the tow trucks, because that's basically predicting future. And that's what machine learning doesn't do. It can give you some estimates based on the statistics. But what you really need to know about machine learning. First, understand your scenario. So all of these scenarios that I mentioned, you need to figure out in which part of the machine learning tree you need to go. Then understand your data. That will give you some understanding on which trainer to pick. And also I'll show you later in the demo, if you apply just tiny bit, a speck of data science, you can improve the result significantly. The machine learning will not solve your problems magically, but if you apply a little bit of common sense and if you really think about what you want to solve and look at the data and see, can I actually do prediction from that data, then it may actually solve your problem much easier than you would think. And the last part is, if you take one line of your data, a random line, and if you look at the columns and you cannot predict the value you're looking for, then there's a good chance that you might need a data scientist, or that the machine learning will not really work the way you want it, at least not with the accuracy you would want it. Okay, so now let's go to ML.NET, now that we have a little bit of basis on machine learning. So you remember how ML.NET claimed that you don't have to have much machine learning experience. So let's put that to the test. So when you go to the web page and try to get started, the thing you're being greeted with is scenarios. And on the front page, there are 9 scenarios. They're quite a bit, but if you go down below on the GitHub samples, you will get like 27, something like that, and they're expanding the number of scenarios over time. So, if you don't find your scenario today, it might come in a few months. And if you look at the process of building a model, I mentioned that head over there is, a black box, a magic that you need to learn. Well, with ML.NET, you get all the algorithms baked into ML.NET, and they're very easy. It's almost like a web API usage of the trainers, the building models and stuff like that. And you need to have like really low knowledge about machine learning to use it. You can just go through tutorials, and the tutorial tells you, you should use a trainer. You initialize the trainer, put a few arguments, and boom, done. But you still kind of need to know what kind of trainer you want to use. So remember those trainers over there? So what if we even remove that variable out? And we start using ML.NET Model Builder. And this is just a wizard on top of ML.NET. And what allows you to do is, you have the data here, and let's just put it into Visual Studio and let it figure out everything. I just, I have this scenario, figure it out. And what it also allows you to do is quickly iterate through your data and see how the model is going to build and work in production, because what it does, it trains the model and then evaluates right away. So you will see when you change your data, whether you're getting better results or worse results. And to show you, here you can download the ML.NET Model Builder. And to show you how this is done, I'll show you roughly how I did my demo, my prototype, getting from bank transaction descriptions to categories. So first, I had to have training data. Now, I was very lucky because my training data was actually my own data in the bank. I then had to use a financial app that knows how to transfer data into the my mobile app, where I could do manual classification of all the transactions with proper categories. And then I exported that to a CSV. And here is the Excel, just to show you a couple of columns. The structure is this way because that's how Toshel is exporting the data. It's not really important, the structure and stuff like that. Different bank mobile apps are going to give you different CSVs. If you manage to get direct access to ANZ APIs, will have different structure. What is important to us is, what category we have set it up and the description of the transaction, because that's what we're going to try to use to predict the category. And the important part here is you have to already solve the problem inside the training data. You have to, so we want to predict categories, so we need to actually fill out all of the categories. We cannot just remove the column and say, hey, try to predict category. It's like, I can't predict from nothing. And to start, in Visual Studio, we are greeted with with similar screen as before. We need to pick a scenario. So here we have 4 scenarios. So with ML.NET Model Builder 1.0, there were only 3. So they're slowly expanding it, and hopefully they're going to expand to all of the scenarios they have on GitHub. But right now there's only 4, and ours is in, which is issue classification. And we are greeted with Add Data tab. So what we do is we add our CSV. We then select the column we want to predict, which is in this case category. And then we see down below a preview of our data. And now this is the most magnificent part. When I click Start Training, the old theory that I was talking about earlier happens here. Here it makes the decision, should, based on the training data, take neural network, or should I take decision tree? Should I do multi-class classification? Should I do binary classification? Well, there's even one case where it uses multi-class classification with binary classification. And, I didn't do anything. It's just like, yeah, run it. And I was like, when I look at documentation, I was like, oh, average perceptron over is actually multi-class classifier with a binary class classification. I was like, yeah, cool. Didn't have to do anything to use that. And the second last step is evaluation, where you see the stats of all the trainers, how they performed. And one thing that I notice is, say, I want to pick the second one, the scatter maximum entropy multi, because it's a tiny bit faster, and I'm like, yeah, I don't care having a little bit lower macro accuracy. I'm fine with that. I want to have it fast. At the moment, you can only pick the first one. You cannot pick any of the other ones. So hope Microsoft fixed that. But otherwise, all we have to do here is just go next to code. And when we are at code, we add project. Boom, project is done. And we get these 2 projects. And the second project is the one that you probably will use the most. Is it actually contains the model, which is zipped. And it has a magical structure in it. I don't believe they documented how the structure of that is. And then you have model input and model output, which basically mimics of what columns you had as an input. And what you can now do is take this and put into .NET Core, .NET Framework, Xamarin. It's just .NET Standard Library, so you can put it wherever you want. And the second project is a console application where it tries to show you how you can use ML.NET with help of this class down below. And what it also allows you to do is retrain the model with the new data on your machine if you'd like so. So you don't have to rerun all the wizard again to have an updated model. Okay, finally, let's start with the demo. So I'll go to Visual Studio. Minimize that. So the weird thing here is you do have to have a project inside a solution, because when you do add and here machine learning, that's only available.
Are you guys okay with the size of the screen?
Okay. The size of the screen seems to be okay. So this context menu is only available on project. Now it creates 2 projects, so it's a little bit, why do I need to have a project in a solution if I'm going to create 2 projects out of it? So I hope they'll fix that. But once you figure that part out, here we're greeted with classification. Here I'll pick from back unfiltered. Now, if you have data in SQL Server, you can also select SQL Server. I'm having here from File, and here I'm selecting Categories. And I train, boom. So now all that theory is just, running in the background, and I can just chill and not bother learning machine learning. And done. And here we have evaluate. We have a bunch of stuff. Now, if you click this one and try to go code, it's not going to select it, unfortunately. Now, for the eagle eyes, you will probably say, hang on, there's one weird column in there, tags. And if you think about it, where that data comes from? Well, it turns out, the Toshal application I'm using has categories and tags, and I populate both of them, and they're both manual inputs. And when a transaction is coming from my bank, I won't have tags, neither categories. And, here it says it's 95% accuracy, but that accuracy is actually coming because of tags. So what I need to do now is basically remove all of the columns that I cannot predict when the data comes in. So I will go into my data, I'll open it up, I'll select this column, and I'm going to delete it. Save it, close it. Always close Excel, because ML.NET Model Builder will fail if you don't, with weird errors. So you've been warned. So when I'm trying to retrain, now you can see that the accuracy fell for 10%. And that's now more accurate representation of how it will perform in production. But I can tell you that with a pinch of data science, I can make it better. So if I go to data, and if I expand this column here, date. Now, with multi-classification or classification in general, any noise, anything that is not repeatable, will result in a little bit worse results. So if the data is not relevant or is very noisy, it may actually result in worse results. And to prove you this, because there's very little correlation between me going buying a coffee at that exact date and classification coffee. Like I'm going to coffee every specific date. Now it would be different if I would have day of the week. If it would say Monday, I could have something like on Monday, I'm having coffee with breakfast. But on all the other days, I don't have a breakfast. So let's close that. Retrain. So right now it's 85%. It grew up to 86%. So I am removing columns, and now I'm getting better results, just because I have a pinch of data science knowledge. Now, if I go a little bit further, that's mostly because it makes the demo a little bit more convenient later on. I'll remove all these redundant columns. Income, because I have no income. Currency, because it doesn't actually give me any value. Here, main currency also doesn't give me any value. And this and this column are essentially the same. So I'll just remove all of these columns. You know, less things you need to input, the better. And if I train it again, with a little luck, we will have slightly better result. Nope. Now, you can run this for 60 seconds and you will get exactly the same result, and it won't change at all. But you can run it 6 times 10 seconds and you'll get a different result every single time. So I found that you should train in short bursts multiple times to try to get the best result rather than for a longer duration. Not sure why, but it's probably how they are picking different trainers. So I'm happy now with that. And now I'll add the project. And here we have the project. If you look at the input is just defining the input structure. It tells you what was the original column name and has the properties. Let's try to build this. And the model output is the prediction column. Now, it changed from category to predicted label because it no longer reads that information from that Excel. It now reads from the result of the model. So it transforms the data, and then the result that it gets from that model is the predicted label. And you can also see here we have an array of score. So what that is for each possible classification, for each possible output, it will give you what were the confidence level. So for instance, even though you're getting back, say, for a bank transaction for coffee is coffee, it might also tell you maybe it was a 40% food. Or maybe it was has word hotel in it, and it will say, hey, I'm like 20% sure it's accommodation. And if we look at the program CS, and I'll quickly switch this to that so I don't forget. Here you can see Microsoft generated code, the path to the model, the path to the original CSV. So if you commit this to GitHub, make sure you change this. So it's a relative path, not an absolute. Now, how many of you have worked with DB context and know EF Core or Entity Framework? So we have quite a bit, actually. So for those who don't know DB context, it's just a class that can work with the databases. And similar thing is here ML context. It's an object that knows how to load models and do things with models. And you can see this already in the next line. We're using ML context, and we say, hey, we want to load a model. And we have here iTransform. As I kind of suggested at the beginning, model is like a transformation from the input into an output. And this gives you even more, that hint, like that's what it's doing. And the last step before we use the machine learning is to make a prediction engine. So what prediction engine does is saying, hey, give me this input structure, give me the output structure and the model. And now I'll figure out how to get the input into the model and how to parse the output. Now here is just a Microsoft code to get a random sample from the Excel. And this is the actual use of the prediction. So we are just using prediction engine and we put the sample data. The sample data is just the input we seen before with the count, category, expense amount, and description. So if I run this, you'll see the best UX I have ever seen for outputs. So instead of explaining you what this is, I'm going to cheat a little bit, and I'm going to make a real output and replace this one. So okay, this is now better, isn't it? Now we can actually read what data we're looking at. So here you can see that from the CSV, it took a random sample Spotify, it identified it as leisure, and you can see that it was 82% sure that this is leisure. So what I can do now is just to show you that it's working. I'll take this transaction here, which is .NET Foundation, a donation I did a few months ago. I'll paste this. Just need to make this code right. And I will run this. Now you can see that I'm treating this as an investment, and you can also see that here it actually has, for some reason, a pretty huge percentage for food. Now, it's not too concerning yet, but if it would start to grow over time, I would try to look at my data and see why does it think this is food. But this gives you an insight. Like if something is being classified incorrectly, it's like, why is it so? And then you can see maybe one of the classification is 40%, and the one that you're looking for, but the wrong one was 60%. So you need to figure out, okay, why this 60% had more confidence than the 40%. Once you figure that out, you use a little bit of data science, or sometimes just look at the description and see what parts are the same with the other categories of the things that it thinks it is, and fix that a little bit, and you're good to go. Now, there's also one small caveat with ML.NET Model Builder. So here I'm dealing with 3,000 lines of code, but I don't really have many transactions from here. So what happens when I do a small change? Well, now it thinks it's food and drinks. In fact, it's actually pretty confident it is food and drinks. And what happens is the food and drinks sometimes becomes that else statement. It's like if you don't know where to put it, try food and drinks. Now, I have tried rerun this model, the ML.NET Model Builder with this training data a couple of times, and in certain cases, it actually put it into unsorted, which is like, yeah, I want that. But the problem with machine learning is, you give the data, then you put into training, and you don't really know exactly what's going on. You're never quite sure what the end result is going to be, which is why Microsoft is suggesting, hey, maybe do some unit tests, and if the unit tests are failing, maybe just retry to train the model. This is actually quite a good joke from XKCD where they were like, they want to steer the data. So if they get wrong data, they just try to steer the data a little bit longer into the machine learning algorithms, and they will eventually get it right. And, you know, there's also another very interesting thing that I learned. So if I switch this back, so keep an eye on those two values. Now, what machine learning sometimes does is, you know, I increase the expense amount, right? And this suddenly rose for almost 5%. It's like, okay, interesting. But, you know, still I still got the right one, right? Well, I raise it for another 1,000. Why is it pretty sure it's transfer? Well, this is one of the pitfalls of machine learning as well. You have to kind of understand your data, because all of my transfers between accounts were usually a little bit higher, like in thousands, because I was transferring from my main account into debit account or into credit card or savings account and stuff like that. And it's just like, okay, if it's a big number, then it has to be transfer, because there were no large other transactions. And, you know, it gets the wrong correlation. So this is why you shouldn't quite just take this, okay, it works for our test data, and ship it in production. Do a little bit of testing before you do that. But there is also another thing. Like I showed you how when you change this, it won't work. Well, before ML.NET Model Builder came out, I actually did my own ML.NET application. If you like, I can show you the code after the session. I'll also, once this goes into YouTube, I'll link a GitHub URL where I explain how I built that model with ML.NET custom. But what happened is, because I understood the data, I picked the right trainer, I did the right arguments, and the ML.NET Model Builder is very close to my implementation, but just got a few things wrong. I haven't quite found which ones. But here you can see, not only I can change over here the values, whatever I want, I can even remove all the fluff around it and add some random text, and it's going to work. And this is just, you know, you can use ML.NET Model Builder to, you know, get your first prototype out. And if you don't have, you know, varied inputs, like either you have a really big data set, or your inputs don't really differ much. Say you have, you just want to have a really simplified rule engine. That's really great, but if you do something else, you'll need to test it and play a lot with your data. But if that fails, there's not really that much you need to do in code to improve it and get something like this, because this is something I'm using every week. And in the past, I've been manually classifying bank transactions every weekend for 15 minutes. And now this is doing my job. Now every month, I'm just scrolling through all the transactions like, this one is new. I'll classify it so the next time it will recognize correctly. And, you know, I'm done in 5 minutes. And it's much more leisurely work rather than, you know, clicking all the time and save, clicking, save, clicking, save. Now that this does my job. Now, how many of you would like to use ML.NET Model Builder? Almost whole room. That's great, because I have a few more caveats before I finish if you want to try this at home. So I have done a very, very difficult model builder. It's called rock, paper, scissors. And I'm training my machine learning to know how to win rock, paper, scissors. So if I get rock, use paper. Now you would think, yeah, that should just work, right? Well, if you do custom ML.NET, you can just select the right train and stuff like that, and it actually works. But what happens is, for some reason, it doesn't work. Now, if I do it manually, it would work. What it turns out is, it's not really the problem of data, like that we have only 3 unique data, but for some reason, if you don't have exactly 100 or more rows, when you try to train it, it will give you no result. So here I have imported exactly the same thing, but I repeated it, so I get a little bit more than 100 rows. I train it, and now I have 100% accuracy. Now, as I said, you can do this in ML.NET, manually load data, manually configure trainers, and it's going to work perfectly. So it's not like the ML.NET doesn't support this, it's just ML.NET model builder doesn't really know what to do with such a small data set. And just to drive this point further, here I had a more curated bank transaction details, but the problem was it only had 70 lines. And now we have a more different problem. When you start training, it's like it has a 50-50 chance of success. Like, that's a weird number. Like, it's the perfect training data set. How can it be 50%? I mean, if it would say 49%, I was like, okay, I guess I did a mistake, but 50? No, there's something wrong. So it turns out, if I just take, I don't know, from here, just enough to get over 100, are we only 100? Yeah, save that, close this, train, and 100%. I thought, okay, maybe it's taking half here and half here, and that's why it was 50-50. But you could just take something from the middle and paste it on the bottom, and it works. So it's just probably a limitation in ML.NET Model Builder, and I even tested it. I removed 1 line, so I had only 69 lines, and it didn't give me any results. So 50% is somewhere between 70 rows and 100 rows. So yeah, that's if you're playing around and you're having these issues, this is why. Have more than 100 lines of code. So what did we learn from the demo? Well, ML.NET Model Builder is basically just importing CSV. And if we tweak the columns, we get much better results. We don't have to be data scientists for our first prototypes. Now, obviously, if you understand more about data science, you'll get better results. You can then generate the project with ML. The second project that has the actual model is the one that you can share around with your mobile applications, web, and stuff like that. You don't have to use the console application. We learned how to use machine learning model. And I showed you some weird, quirky things that happens with the ML.NET Model Builder. And I achieved my goal. 3 weekends. At least those 15 minutes. This is a nice joke I found on XKCD. So essentially, if you manually tag everything, you already have the training data for the machine learning. And that's basically all the work you have to do with ML.NET Model Builder. And with that, thank you. So does anyone have any questions? And where's the microphone? Ah, over there.
Hi, is this on? All right, cool. So just a quick question. The ML.NET said that it's available on Linux and Mac OS.
Yes. So
in the builder, it had a UI. Would that be in Visual Studio Code, or is that only command line?
So for that we have, so the question is for ML.NET, if it's supported on Linux, Mac, and other platforms. The quick answer is the SDK, yes. The ML.NET Model Builder, no. But you do have a CLI, AutoML, that basically gets all the same inputs as Model Builder.
Thanks.
Yeah, no worries.
Have you seen the latest? It's got an API. Oh, have you seen the latest? They've got an API for the Model Builder as well now.
Oh, they have an API for the Model Builder. No, I didn't see that, but yeah, thank you.
ML.NET audio files, like speech recognition?
Does the ML.NET work with audio and speech recognition? Not out of the box, but you can transform the data in such a way that it would understand. So for instance, it does have image recognition. So, but yeah, you probably would need to learn in what format you would need to do the audios in order to use it in ML.NET. So the question is for ML.NET model. I don't know exactly what's going on there. I don't believe they have an official documentation for that. But it's a lot of folders in it. Can you give?
Because the way sklearn works, is that working?
Oh yeah, it's directly to
you can have ensemble. It basically can create an ensemble of models. So it's like that, but they've somehow, I don't know, why do they have to serialize it to a zip file? It seems ridiculous. Yeah.
I would not know, unfortunately. I'm just happy that I can do quick prototypes in machine learning, and once I get to a point where I'm like, I want to improve this by a large degree, I can then decide to either go TensorFlow or the Microsoft CNTK, which is Cognitive Network Toolkit, yeah, and even dabble in deep learning, which you can use in ML.NET, but I don't believe you can train deep learning.
Well, you only got 3 models now, of 3 types.
Excuse me?
You haven't got, there's no neural networks yet, so
yeah, it is, but deep learning is the process is a little bit different. Yeah.
If you got a model trained by TensorFlow, like a .h5 model, can you load that into ML.NET?
Yes, they basically pride themselves that you can use Onyx, TensorFlow, and I believe a couple of other ML models from other third-party providers. Yes, behind.
So just one quick additional question. You mentioned earlier that you trained a model with 100% accuracy.
Yes.
Are you not worried about overfit when you train a model like that?
Yeah, so the example that I showed you where I changed one number and it didn't work is because of overfitting. But what you can do is with AutoML and Model Builder, you can quickly create the project, see if that would work in your environment. Is the data even something that you can use in machine learning? And when you see, okay, we have an overfitting problem, you can customize the codes to have to use a trainer that has less of a problem with overfitting, or even change the data itself to mitigate that problem. Yeah, previously you would have like spend a lot of time just to get to the prototype stage. Yes?
Is there any documentation about the trainers themselves, or how can you build one?
Yeah, I am actually amazed by ML.NET trainers. I believe that is going to give me right the page. So yes, this is like linear algorithms, and it tells you different trainers. You can look up what they do, and they even tell you which trainers are using decision trees, which one uses linear algorithms, which one are metrics factorization and stuff like that. So you can then really figure out what's going on and what would be the best option for you.
There's one really good point that I found out about it is that the data view supports vectors. So you can have a row that actually has a set, like an array of arrays. So you can have a set of data. So that's what I need for my stuff. You know, so that's a really good feature. You won't see that in any other in pandas at all.
Oh, okay, yeah.
How would you suggest ML.NET for large data sets, like millions of rows and performance-wise with other libraries?
So there's one neat trick when you go into Model Builder and you put a ridiculously low number for training, and you're trying to train based on that. It will actually tell you, if it's less than 10 megabytes, use it 10 seconds. If it's like 1 gigabyte, use it like 120 minutes. So the answer is, yeah, you can use it for 120 gigabytes, and this is roughly the scaling.
Is there any support for GPUs, like CUDA?
So we actually tried this in, let's put this 20 seconds, and I'll go Task Manager. Now you see the secret of my clean desktop. So if I go to GPU over here, and I do always on top. Come on. Come on. And put NVIDIA. We should see some activities going on. Is it Intel? So the answer is yes, although let's cancel it. Should we see a... But it doesn't seem to use in this data set. At least, let's see. Okay. So you can see over here, it's another bump, but it doesn't really use a lot of GPU. So it's not like utilizing 100% or anything like it.
I think the algorithm has to support the GPU breakdown, otherwise it's not going to work.
Okay. Yeah, because I've seen on another one better utilization. Okay, good point. Yeah, any other questions? Otherwise, we can wrap this up, and you can come to me directly, and I can give you some answers. And I think we should wrap this up. Thank you for coming.